And share screen.
All right. So, as I was just saying to my fellow co-hosts here, nothing fancy to start this thing off. Just welcome. This is Cloud Native New Year, week 3. We're going to run through the week's posts, try them out live, and see if the content we put together works. I'm Steve Morawski, and I'm on the cloud advocacy team at Microsoft, focusing on cloud native. With me is Paul Yu on my team. Paul, why don't you introduce yourself and then
Yeah.
introduce our guest?
Yeah. How you doing, everybody? Paul Yu, also a cloud native advocate on Steve's team, and happy to be here. Michael.
Awesome. My name is Michael Levan, and I do everything and anything Kubernetes and containerization. Thank you guys for having me. Appreciate it.
Right on.
Oh,
Appreciate
our
you being
pleasure.
here.
Yeah, you can keep us honest. Make sure. So, yeah. All right. Let's dig right in because we've got a lot of stuff to cover. So we're going to start off with some of the content from day one. To introduce the app that we're using, so let's add this here. So introducing the app, we started with the eShop on Web application. And the eShop on Web is a .NET sample. And let's just pull some of this up here. So it's a .NET sample. We forked that repo. We got it available with checkpoints for each of the day's content. So like if after you go through day 1, we have what the repo would look like, in a branch, and same thing with day 2, day 3, all the way through day 5. So you can play along and then take a look and see how what you did may or may not differ, or if it looks pretty well like what we've got. Then you're there we go.
Yeah, lost you for a second.
Yep, that had a little blip there. I'm just gonna make sure QoS is set to my machine. I jumped over to a different docking station, so I have a different IP address now.
Mm-hmm.
But the main point here is we've got this traditional line of business app. We picked .NET. The principles are going to apply to just about anything because we're not really changing too much of the application environment. But the point being is we could if you want to move into Kubernetes, you don't have to go and break up your app into a bunch of microservices to start. There's a lot we can do with some minor changes to our runtime environment and to how we build and deploy our code to get into Kubernetes, and then we can start extracting microservices and doing all sorts of fun stuff there. Because if you go look for the sample, there's a sample called eShop on Containers, where it's all broken up into microservices already. You don't have to block on that to start using Kubernetes today. All right, let's get into the actual work. And
It's all about starting small and iterating, right?
Exactly, right. That there's actually a benefit to starting small somewhere and then making the small changes rather than breaking everything up right away. Because when you make those changes in a bigger batch like that, there's a whole lot of stuff that could go wrong. And now you're running in a new operating environment. And one of the things we'll actually touch on is how do I actually get into that operating environment and start to understand what's going on? But we'll get there. Let's start with some of the things that we want to do to get going. And rather than walking through each individual step that we've got spelled out, because there's a lot spelled out in the day 1 post, I'm just going to drop in and check out, and I can point out some of the things that we've done here. So we've added a couple of things to our workflow environment here. And it looks like I forgot to uncomment a few things. That's okay. We could actually leave these actions.
Now, are these the steps prior to actually writing the Kubernetes manifest, or are the manifests already written as well?
So we've got some manifests written here. So we talked last week about writing the manifests, and so in the post, I refer to using those same techniques. And so Paul actually had a great little trick of using the kubectl command to help scaffold out some of the start of our YAML files for our manifests. And so to start this exercise, we'll start with we start with some deployments and some services to sit in front of these things. And the couple of the little difference that we did for this deployment compared to what we were doing last week. Last week, everything was all imperative happening, from your workstation. Here we're introducing bringing in some GitHub actions to do some of this for us. And so the first thing we do is go out and build out that AKS environment. And it's basically the same AKS environment that we built last week. It has an ACR, it has our Kubernetes cluster, and verifies that, so that on each build, it's going to verify that that environment is in place, configured as we want. Then we move on to publishing our container images. Now, the workflow for that, and in the post, I go into a little bit more detail about how you make a composite workflow or a callable workflow so that your workflow file isn't exploding all over the place and making it hard to troubleshoot. You could also reuse components of this, as multiple steps. But we go and we build our Docker container. And one of the differences because last week we had Azure Container Registry build our container image. Here we're building it in GitHub Actions. And we're tagging it with the GitHub SHA. So that's the SHA of the commit, and makes it really easy for us to tie back what's in a container image to our source repository at a particular point in time. And of course, we want to start thinking about security in our workflows. And so we add a container scan of the two containers that we're building. Though I'm catching typos here.
How is that scan happening? Is that like is that using something internal, or is that going out and using another tool? I've never seen that GitHub action before. That's why I was asking.
So it uses Trivian Dockle.
Okay, gotcha.
Yep. So there's some open source container scan images or container scan image engines that identify CVEs as well as best practice violations. And our base container image actually has a few of those things. So to allow our demos to run through, we've actually identified them. And not every CVE is a showstopper. Right? Not every best practice violation is a showstopper, but the practice of actually then going through and then documenting them in here, you get to make an intentional decision about whether or not this one matters for your environment. So for the purposes of this demo, I'm going to allow any of these things to not fail my build.
And and that's exactly it. Is that it may not be a showstopper for your organization, but it will halt the build. You can't move any further than that, which is a good thing.
Yeah, and funny enough. Oh, sorry, go ahead.
Go ahead.
Oh, I was just gonna say, no. Funny enough, I was creating some content today with Kubescape, which is Armo's product that does the container image scanning and the repo scanning and cluster scanning and stuff. And I was pretty much saying the same thing in the content. I was like, you could have a high vulnerability, whether it's from NVD, from CIS, from NIST standards, whatever. But that high vulnerability may be high to you, but for another organization, it may not be. So I feel like it always just kind of comes down to where you're working, what the compliance needs are, et cetera. Unless it's like a a 0 day or something like that where everybody should be worried. But
right, and in some cases, right, like your code might not execute or might not exercise the vulnerable aspect of wherever that vulnerability is coming from. So, you can make those decisions, once you see the details of what those CVEs are. So the visibility is a good thing, right? Like knowing that those CVEs come into play, knowing that those best practice violations come into play, allows you to make an informed decision, right? It's removing that hidden risk.
Totally. Yeah. And I feel like I've never seen a base container image that hasn't had some type of vulnerability, like regardless of what tool you're using. Like if you use Docker scan, which is using sneak, however you pronounce it, in the background, and like you scan it against the Nginx container image or whatever other base image, like there's always something in there that'll get flagged.
Oh yeah. And as we were putting this content together just over the last week or so, and this is looking a little behind. I wonder if I cloned the wrong. We've been working across a couple different repos, but there should be a 2023 CVE here as well. So I'm gonna have to go back and check that repo, but because if we go and yeah, I think we're missing a commit or so there on week 1, but we'll figure it out. We'll figure that all out. We'll see when things fail. So then we sign into Azure and push so we can log into our ACR, and we push the containers there. And then the final step gets those manifests that you mentioned, Michael, where we deploy out to AKS. And so we pass in the GitHub SHA and our AKS name and all that fun stuff and some Azure secrets, so we can actually run this workflow. Yeah, this is something's not right here because this is not in the right spot. So yeah. I think I've grabbed an old version of the repo. When we flip over and Paul works, I will grab my other one, which I think is in the Azure Samples org, which has the more updated things. Now, this is the hackiest part of this experience. So out of the box, and Michael, maybe you have a better solution to this with kind of our out of the box tooling, but there's not a great way to dynamically provide parameters to our manifests. This is where other tools in the ecosystem like Helm come into play. But for this week, I really didn't want to introduce we're introducing a lot of additional stuff, and it just felt like a concept count too far. So we're using our command line tools to edit files as we go and bring in some of that dynamic behavior.
Yeah, I would say, I mean,
yeah,
other than customize, right? Because Helm for this at least might be a little bit overkill, like, because we're not really trying to package anything. We're really just trying to put in metadata essentially based on what environment, whether you're going to dev, staging, prod. So yeah, I mean, other than customize, but that's not something internal, right? Like I guess the other method that you could use is like you could set up a variables file for your GitHub Actions and pass them all in that way in your workflow, depending on the environment. But that could probably be the only thing that I could think of, like internally, right?
Yeah. So because the GitHub SHA, which is our tag, won't be known until runtime, right? It's specific to a particular execution of the GitHub Actions, or at least to the point of time in code, right? Like I'm probably not going to be running the same build over and over with the same SHA, maybe, but my container image is going to be the same image, so I'd be pushing and it'd say, oh, it's already there. So this is really only going to execute probably once around at a particular point for a particular point in time. So we're taking advantage of that. So we introduced the customize tool, which allows you to provide some overrides for what you have defined in your file. So, for example, in our deployment web, we specified our image as not a valid registry. So we have and we just, it's a static string that Customize knows to look for because we tell it what to look for and then what to replace it with. And these are these values here in the angle brackets are the values that we're setting out. So that's where, our Linux command line tools come to save us, right? And we're back to, line editing. And hey, if it works, and we'll see over as this scenario develops, how that gets uglier and uglier as this process goes. But without bringing in another set of tools or changing the pattern that we're using, this, it gets the job done.
Yeah. Totally. What's the saying? I think underneath any good automation is going to be bash scripts. At the end of the day, you're going to have a bit of
it all devolves to bash scripts or PowerShell scripts or something along those lines, right?
Yeah. What was that Homer Simpson meme where like his back is like clipped and it's like it says, I think it's like Kubernetes in the front, but then at the back it's like YAML bash scripts.
Yeah. I mean, any build system, right? It's it's a bunch of shell scripts kind of holding stuff together, and no matter how many nice wrappers around actions and things that you get, or tasks, or whatever your build system calls them, there's going to be these little bits of shell script tying all this stuff together. Same thing with your make files, or I was having a conversation with one of our other coworkers, and because we were like, so what better automation tooling than we have than just a bunch of bash scripts or just a bunch of PowerShell scripts? And it's like, we find all these things, and there's a bunch of different task runners, but at the end of the day, the barrier to entry, and I'm accumulating all these different tools to go run essentially shell scripts. Just packaging up the shell script is usually usually ends up being the right answer.
Yeah, totally.
All right. So what we've got here now is a complete pipeline. And in the interest of time, I ran this thing yesterday so that we would have a fully stood up, because it takes a little while to deploy out the environment. And I'm just going to get my Azure portal here, and we can take a look and see what environment was deployed out. All right. And so this is the resource group that was provisioned. And we have our container registry. We have a Kubernetes service. There's a managed identity that tags along with this. We have a DNS zone for us. That will come into play later, and some storage. So the main thing being, we have our Kubernetes service. We can take a look at the workloads running there. And what else? We got lots of other stuff here. Let's take a look at. So it's going on we got our default namespace, and we can just kind of drill around and explore all of the various stuff that we have out in the Azure portal. Or we could drop to the command line, which is my preferred place. And we could, get our services.
You might have to do an AZ AKS get, or credentials in.
It's a brand new cluster, right?
Yep.
Yeah.
And I've been building and tearing this down and rebuilding it and tearing it down, rebuilding it. And
Yeah.
All right, now we should be able to see. There we go. All right. So we got some services here. That all looks happy. And we can take a look at our deployments. We see we've got our web, our API, all that deployed. So that is all looking happy. There's a lot more in the day one post. We go into the details of federated identity and setting that up for working with GitHub Actions so that we don't have to provide static credentials. But it's a useful thing, but it's a little out of the scope for kind of focusing on the Kubernetes side of the story. Though we'll take advantage of federated identity later too. Paul's got some stuff on that for us. All right, Paul. I've probably talked way too much at this point. Why don't we hop over to you and talk about our day 2 content, right?
Yeah.
Where we start adapting some of that runtime environment. We got the containers running, but we're probably not in an optimal place for our application to perform.
Right. Because as we demonstrated in last week's blog series, there's a lot of things that were hard coded, like environment variables, database passwords, the local file mounts for the database itself. So if the database container so happened to crash or restart or whatever, you pretty much lost your data, right? And so the second post that we introduced this week was all around configuring your application a little further, refining it with by injecting environment variables into the container, taking advantage of Kubernetes secrets, and going a little bit further than we did last week, right? So last week we just used Kubernetes secrets, and if you've used Kubernetes, you probably know that they're not really secrets; they're just basically foreign coded values. So if anybody had access to your Kubernetes cluster, they could just go right in, get the secrets, and then actually decode them and see the actual values. So what we want to do is introduce a third-party vault system. It could be Azure Key Vault, could be HashiCorp Vault, could be some other vault, but we'll introduce Azure Key Vault here, and we'll take advantage of workload identity and identity federation. So it'll be fun. We do have a pipeline, and it was intentional that we made a pipeline for every single day of our posting. So if you go out to the Azure Samples repo, you'll find that there's a branch for each day of our posts, and this is here so that you can just see all the manifests, see all the workflow, the automation that we put in. That way, you can just jump right into a day's post and go run the pipeline, and it'll set up your cluster the way we ended up at the end of our post, right? So just make sure if you are on the actual repo itself, and when you actually do fork it, you want to make sure that you uncheck this little box right here. That way you can also fork all of the branches as well, and then run them in your own environment. So with that said, yeah.
So a point about that, so if you wanted to say do the day 3 stuff, switching over, pulling the day 2 branch, and kind of setting things up, and then having the GitHub action run from there will set you all up to start the day 3 work, right? And so you can either use it to check what you've gotten to, or you can use it to set yourself up to just work on a particular day.
Right. All right.
So
with
I'll let you get into
it. So with that said, we're not gonna. The best practice is to actually make the changes, commit them to your repo, and then watch the workflow kind of do its thing. Because as Steve was mentioning, I mean, we have a full end-to-end. We're standing up the infrastructure. We're doing all this stuff. It takes about 16 minutes-ish for everything to complete end-to-end. So we're just going to run kubectl commands, AZ commands, just to get our cluster up to date and implement the things that we want to implement. Okay.
Yeah, and we could improve that performance by changing and having the deployed AKS step watch to see if there's been changes to the infrastructure or so. We just didn't do that optimization for for this.
Yeah. All right. So what we're going to be doing, and I did mention that we're going to inject environment variables using Kubernetes config maps. We're going to implement persistent volumes like we did last week with the database server. And so we have a SQL server that houses all of our data for our eShop. And so we're going to need a persistent volume for that as well. So we don't lose data when the containers restart. And then we'll actually put our secrets, database connection strings, things like that, inside of Azure Key Vault, and then integrate it with our pods so that it can go retrieve that. And then we'll just repack everything and deploy our manifests. And at the end of it, we should see no changes, but all the changes are kind of running under the covers to make your deployment a little bit more resilient. Okay. So
yeah.
Go ahead.
Well, and not just resilient, but it'll actually let the database, like the application, talk to the database rather than using an in-memory or local database, right, to run. So the different parts of our application will actually be able to communicate and talk together and actually work together.
Right.
Because right now it would be running off of the app settings that were packaged with the container build.
Right. And I'm not sure if folks have seen the application running yet, but let's just go. Oops, that's not what I want to do. I want to copy. And here we go. So the application is running. So this is what it looks like now. And at the end of it, it's going to look exactly the same. So, so what we have is a database server, and we have one single database server, which supplies the data for our web application, which is the front end. And then there's a REST API service for the back end, and that's mainly for the admin portal. Because if you log in to the application as an admin, you can actually go to the admin portal, which is a Blazor WebAssembly application, and you can actually add parts or add products, delete products, and do all that good stuff. Okay, so one database, two ASP.NET applications. Actually, yeah, two ASP.NET applications and a Blazor WebAssembly application. So let's start by injecting or adding some configuration that we can inject into our pods. And config maps are relatively straightforward. So I like to take care of the low-hanging fruit first. So we'll go ahead and apply that. What we're doing here is we're actually creating a config map called MS SQL settings, and we're just setting the SQL Server license and accepting the end user license agreement. Okay, so that'll take care of that, and then we'll also do the same for our ASP.NET settings. Yep. If you're, go ahead.
I was just going to say, one of the nice things, and many frameworks have this in their configuration framework, in their settings or configurations, is they have a hierarchy of how they look for configuration. And ASP.NET Core will look at an app settings file locally, but it will also look for environment variables that are prefixed with .NET and with ASP.NET Core. And there's a hierarchy in which they look at them. So this allows us to override what may be described as environment in anything that might have been packaged along with the container image.
Good call out. Yes, that's exactly right. Okay. The next thing we want to do is we want to implement persistent volumes for our SQL Server database. Okay. Last week we did the same thing. We talked a little bit about storage classes, and just to reiterate here, typically when you implement persistent storage on a Kubernetes cluster or in a Kubernetes cluster, you have to actually create a persistent volume first, right? So it's like a slice of storage that's available. And what you do is you actually take a claim on that, right? Saying that, hey, I want a little piece of that storage off of that volume. In the case of AKS comes with pre-built storage classes, right? And so you can actually see that I think it's SC. Get SC. Yeah. So you can actually see in a just default AKS cluster, you'll find all of these storage classes in here. And what these do is they actually will automate some of the backend stuff for you. So if you say, hey, I'm making a persistent volume claim, and if I'm using a particular storage class, so in this case, I'm using Azure File CSI dash premium, what it will do is I will just ask for the claim, and then the storage class will actually go and provision an Azure File storage account for me on my behalf. And then I can just use that. So it kind of short circuits the persistent volume bit, which makes it a lot handy. So there's two ways you can use this. You can actually build your own storage class. If some of these default storage classes don't work for you, like you need to set different permissions or whatnot, you could write your own storage class, and we have docs on that. But in this case, this totally works for me, and I can actually just leverage that.
So,
sorry,
go ahead. I just wanted to make a quick call because you had a nice, handy little command line up at the previous. You made an alias for kubectl decay, right? Because you type it so much. Just to make sure that folks know that there's not a out of the box K command.
Yeah, I highly recommend if you are in the command line working with Kubernetes, head out to the Kubernetes.io website, and there's a kubectl cheat sheet here, and this allows you to set up your terminal so that you can, number one, alias the commands, and then you can also, I'm using ZSH, so you can actually include like some command completion things. Yeah.
And super Michael, you were going to.
Oh yeah, I was just gonna say, I think one of I would call it a best practice in the cloud, right, is to have persistent volume claims instead of having to set up multiple persistent volumes. The reason why is because, the last thing that you kind of want to do is have to manually manage volumes constantly and manually create them before you try to claim them. And in the cloud, that's easy because theoretically you're not running out of storage. But like on-prem, for example, that's going to be completely different. Like you would want persistent volumes before you had persistent volume claims because you have X amount of storage on your SAN or your NAS or whatever.
Right. Yeah. And Azure in this case is doing you a favor and creating the storage account for you. But like I mentioned, you can create your own storage class. And you can actually bring your own storage account, so you could pre-provision it if you wanted to. So, but this makes it real easy for me and the demo. So we'll go ahead and create that persistent volume for the SQL Server, and then we'll do the same for our ASP.NET data, because the ASP.NET application, it may need to write some secrets, and so we're gonna just use this as a persistent place for that. All right, now here's where all the fun stuff comes in. We're gonna implement secrets, and we want them to be as secure as possible. So we'll put them in Azure Key Vault. And then we'll use this thing called the Secret Store CSI driver, which actually enables you to mount stores using CSI volumes, right? And you can actually sync the secrets, right, back and forth between Azure Key Vault and Kubernetes secrets. And so if you're updating secrets in the Key Vault, they'll automatically be reflected in the in your pod as well. So makes it real handy. Now, in order to do this, you do have to do a few things, and I don't think I called it out here, but some of these add-ons, like if you look at this command here, I'm enabling the Azure Key Vault Secrets Provider add-on into your cluster. Some of these things that I'm demonstrating here, some of them are in preview, and so you're going to have to enable the extension, which I already did. So you'll have to enable the AKS preview extension for your Azure CLI, and then you can execute these commands. Otherwise, it might tell you and say, hey, we don't know anything about this particular add-on, and you'll just have to run this command, and that'll fix you up. Okay. Now, some of these things also, they take a little while, and so I've I've done this ahead of time, just so we're not sitting around waiting for it. And so when you actually provision this add-on into your AKS cluster using the enable add-ons command, let's get rid of this. I don't need this command here. What you'll start to see in your cluster is we have a CSI driver. The driver is actually what allows you to use secrets via CSI volumes. And then you'll also see this provider, right? So we have the CSI driver and then the provider. The provider is actually where you go and configure your secret store class, right? And that's where you say, here's my key vault, here's my credentials for it, and these are the secrets that I want to pull out of it and sync them into Kubernetes secrets. And we'll do that now. But before we do, we need to actually go create a key vault because I don't think we have one yet. No, we don't. So we'll run this.
You need one.
Yeah. We'll run this command. Key vaults are relatively quick to create.
Do you have your RG name set?
Good question. Let's see. Oops. Echo RG name. Yeah.
Yep. Okay, you're good.
Let's do that. So then what we're going to do is we're going to execute this command to create an Azure Key Vault, and then we're going to pull out the Key Vault name, and then we're going to use that variable in a bunch of other commands down the line. So once the Key Vault, yeah.
So while it's creating, I just had a question for Michael. So do you see other secret stores in use other than like native Kubernetes secrets across the ecosystem?
Yeah, well, to your guys' point earlier, the best practice is to never use Kubernetes secrets because that default OPAC standard, what it does is it stores your secrets as plain text in etcd. So if anybody has access to etcd, they're able to pull those secrets. So that's kind of the unfortunate bit there. It's just base 64. So typically what I see just in a general term is I see a lot of HashiCorp Vault used. But of course, if you're in Azure, I see a lot of Key Vault used as well. Yeah, it's typically one of the things where if somebody wants to not stay in the cloud for it, so to speak, I'll see HashiCorp Vault used, or whatever cloud they're in, they're going to use the secret store there. Yeah. But obviously with AKS, using Azure Key Vault, using Azure Active Directory for your OIDC solution, it's built in, so you might as well just do it if you're in the ecosystem.
Right. Right.
All right. So you went and added you got the Key Vault created and added those secrets. Then, Paul. Okay.
Yep.
I'll let you continue on.
Yeah, so we have a database password for the actual SQL server itself, and then the two connection streams. There's actually one database server, two databases inside of it. So there's a catalog DB and then an identity DB because the eShop runs its own identity solution. Okay, so now we have secrets in the Key Vault. We want our pods to actually retrieve those, but right now the pod has no way of authenticating. And so what we're going to introduce here is this whole concept of Azure Workload Identity, which is actually the successor to pod identity, right? So this is where we want you to migrate into. But as of right now, it's still in preview. So there's that. Okay, one other call out before you do this is you have to enable, because like I said, it's a preview feature, so you have to enable that in your subscription. And you only need to do it one time per subscription. But this does take several minutes to actually register the provider. So just a bit of warning there. Okay, I'll go ahead and start kicking off some of these commands, and then I can kind of talk through it as it might take a little while. So the way we're going to do this actually is we're going to enable, first of all, we're going to enable the workload identity feature in your AKS cluster, and also enable the OIDC issuer endpoint inside of your Kubernetes cluster as well. And as I talked to that, I just realized I already ran this, so I'm not going to do that. Okay. What we need to do, so remember that there's a OIDC endpoint in the cluster. Okay.
Was OIDC called out already? What it is?
So, say that again.
Oh, I was just asking. Did we already give the definition of OIDC?
Good point. Open ID Connect, right? So that's a very common authentication protocol / workflow that a lot of the modern authentication is built on. And so I put a link at the bottom here. If you're really interested in that dance, in the way the authentication works, head over to this doc over here and you can just read all about it. And I'll talk to it a little bit more, but yes, good call.
Yeah, I always like to think about it as like just your authentication, your authorization kind of in one. I definitely prefer an OIDC solution over trying to mingle with standard RBAC built into Kubernetes, because it can be definitely a bit of a hassle.
Right. So what we're going to do is there is going to, we do have to have something on the Azure side that is going to be able to act as our client that does that requests the authentication. And so what we're going to do is leverage Azure Managed Identity. Okay. So I executed this command to create an identity resource. And so we should see it dumped into our resource group now. It is workload, AKS workload identity. I don't see that yet. Do you see it yet? Maybe if I
managed.
Yeah, maybe if I wait a few minutes, it'll show up. But there is going to be this brand new thing in the resource group called AKS workload identity. This is basically a entity inside of your Azure AD, right? So Azure AD knows about it, but it's all managed within the resource group. And so lifecycle of it all is all in your resource group. So as soon as you delete the resource group, then so will the identity. So that makes it really handy. So I created a managed identity. I also need to create a service account, right? And so one of the benefits of this particular solution is that it's using native Kubernetes constructs for that authentication. So what we'll do is this.
I just checked. It showed up in the portal now.
Oh, okay. Yeah. You had to just give it a few.
Yeah, I just needed a little time to catch up.
Oh, yeah, there it is. So AKS workload identity. Perfect. Yep. So now what we need to do is we actually need to tie the managed identity with a service account. And we do that using some special annotations on the service account. And a service account is, I mean, if you just think in the on-prem world, it's pretty much the same thing. It's a non-human account that you would use for automation or for whatever jobs that you might have running, right? So it's a same concept. And this particular annotation here actually calls out the client ID of the managed identity. If I click on this workload identity, you'll see the client ID over here. And so that's what I'm doing. I'm just tying that to the service account and setting this label to true so that it will use workload identity. So let's go ahead and create that service account. And this service account will actually attach it to all of our pods that need secrets. So when the pod says, hey, I need a secret from the Key Vault, it'll actually use this service account, which is tied to the managed identity, and then it will be able to authenticate. Okay. It can't authenticate at this point yet, because remember, there's a OIDC issuer URL inside of the Kubernetes cluster. And so what's going to happen is the OIDC endpoint is going to hand, and if I just go back to this drawing real quick, there's an OIDC provider here. It's going to hand a token to the service account, and then it's going to make the request up to Azure AD. And then Azure AD is going to say, okay, what entity is this assigned to? It's assigned to the managed identity. And it's just going to exchange its token for an access token. And then we'll be able to make a request against the key vault. Okay. So let's do that. And let's do these two commands. And then what we'll do here, in order for this to actually, that authentication dance to happen, we actually need to federate the credential. And so we're tying the OIDC issuer URL, the subject, and the subject contains information regarding the service account, because when the authorization comes in, that's what the subject is going to be set to. And then, of course, the managed identity. So let's go ahead and do that little bit there. And then let's just grab our tenant ID. Okay, now I talked about the secret provider class a little bit. Here's what it looks like. Little bit of code that you're gonna have to write. But the gist of it is that, and it's all documented in the, there's a GitHub repo for the secret provider class for Azure. You would actually pass in the parameters. You would tell it what sort of authentication method you're using. In this case, we're just using the client ID. In the past, well, actually, some folks may still be on this, but we highly recommend you to get off of pod identity. But you could specify pod identity if you wanted to. You could specify VM managed identity as well. But here's the trick. The trick is down here. Number one, you're going to pass in the key vault name with the client ID. And you're going to have to define what you want to pull out of that key vault. Okay. When you just pulling it out of the key vault is one thing. Remember, I said we want to mount it using CSI volume, and we want to be able to sync between that. So the trick to do that is actually defining the secret objects. And once you add this block or this stanza into the manifest, this allows that syncing to happen. Okay. So I think I copied it to my clipboard. Yep. So we'll go ahead and create that. And then the final thing we have to do is Azure Key Vault is a really, it's a super secure thing, right? It's like secure by default. Nobody has access to anything in the Key Vault unless you explicitly grant it access. And so that's what we're going to do here. We're going to set a Key Vault policy, which basically allows the managed identities client ID to just get secrets from the Key Vault, nothing else. So can't insert, can't update, can't delete, just get. Okay. Yep. And so that was, that's all the things or the activities that you need to do to kind of tie the Kubernetes cluster with your pod and your managed identity and the key vault all together so that it can go pull secrets for your pod. So now we go back to the manifest because now we have to implement all this stuff, right? So remember, number one, we deployed the config map. And so we'll actually load, this is our database manifest. We'll actually load the config map directly into the environment variables. We'll also set the service account name on the pod to be the service account that we just created. And then we will actually take advantage of the persistent volume claims that we created for the database. And so we're creating two volumes here. One is against the PVC, and then the other one is actually against the secret provider class that we just defined. And then from there, we just mount them in. And so you can see here that we are now referencing these secrets that are actually in Key Vault, but we're referencing them as if they're Kubernetes secrets, but they're not. Okay. Well, they are, but they're sourced from Azure Key Vault. So we'll go ahead and apply the manifest for the database.
Yeah, I would
And
just do a quick call out really quick if that's okay.
yeah,
The setting the service account in your deployment, this is just a good best practice for everybody to do as a whole. You never really want to use the default because there is a default service account in Kubernetes that, like, if you don't specify the service account, all pods get created or and all resources in general get created with the default. But the problem with that is, thinking about security, we want to mitigate as much risk as possible. If you use the default service account for everything, all deployments. And if that service account gets compromised, guess what? So does every Kubernetes resource. So you always want to, try to split that up and not use the default service account as much as possible.
great call out. Yes, absolutely.
See, that's why we got you here. help keep us honest and provide some of that additional context that will be very valuable to folks who are digging into this.
Absolutely.
And kind of along the same lines is this SQL Server container that we deployed actually runs using a non-root user account. Okay. And so in order because we're mounting the MS SQL Server path based on the PBC that was mounted, because it's using a non-root user account, we actually had to pass in the security context into the pod as well, because this is the only user that has access to read-write data from this particular location. And so that's why you'll see the security context up here. Okay. So why don't I just go ahead and create the rest of these? And that's a bunch of stuff flying by.
And if you wanted to kind of just jump to a point in time where stuff was all done as part of your pipeline, the week 3, day 2 pipeline will set all of this up for you. Yeah.
And this will eventually load up.
It's thinking about it.
Yeah.
Yep. Yeah. So when he applied all those changes, that's restarting those pods so that they can pick up the new configuration.
Yeah. Sure. And reseeding the database.
Yeah.
So we'll give that a minute. I think I put together the next post too. So let's just go ahead and jump into
right
that.
In.
Yeah. So the third post of the week was all around exposing your application using Ingress. And so we want to, number one, right now we're accessing it, and it did load up. We're accessing the site by IP address, but I mean, who remembers IP addresses? And so we want to actually implement a custom DNS on our application. And of course, with the custom DNS, we want to implement SSL or TLS certificates. And what's the third thing? So TLS, DNS, and Ingress. So we want to be able to have one ingress point into your application, because right now, get service. Right now we have an API, and the API is actually exposing a public IP because we set the type to be load balancer. And when you do that in the cloud, you get a public load balancer with a public IP address. And so we don't want that. We want our application to look like a single application, and we want it to actually serve API requests when you request, the domain name /API. And so a service won't be able to do that for you. You have to bring in an ingress, and with the ingress, you can configure routing rules and whatnot. Okay, so 3 services we need to take care of. So the database is fine. It's using cluster IP, and that's perfectly okay because it should only be accessible from inside the cluster. But these 2, we'll go ahead and fix these up. And we will do that by revisiting the web application routing add-on for AKS. Last week, when I wrote about it, I only implemented the ingress portion, right? And so what that add-on gives you is a open source Nginx ingress controller. So Microsoft or the Azure team will actually deploy that on your behalf, and they'll actually support it as well. Whereas if you were to deploy it on your own using just open source manifest or a Helm chart, you're kind of on your own in the support. And so I like free support. I want Microsoft to help me with my troubles there. So I'll take advantage of this particular add-on. Okay. And remember, this is also in preview. So you have to enable the extension AKS preview for that. Let's see. I pre-provisioned some stuff here for the sake of time. So there is actually a custom DNS that we're going to use. Okay. So eShop on web 28911.com. I just made it random because these domain names, they need to be unique. So the couple things that the web app routing feature gets you. Number one is the Nginx ingress controller. Number two, it can actually integrate with Azure DNS and Azure Key Vault, right? So as you're deploying your ingress resource into your cluster, it's going to use a special class for that. And that special class can actually, on your behalf, write DNS zone records. So when I deploy an ingress, what's going to happen is I'm going to get an A record written into this DNS zone. And it can actually pull TLS certificates out of the Key Vault and present that for the website. So let's go ahead and do that. Let's create a self-signed TLS certificate, because this is not a real domain name. Okay. And then we will export the PFX file because that's what Key Vault wants. Okay. Let's see. Grab the Key Vault. Yeah, I want to do that. And I just want to call this out. If you set up your cluster using the automation, like let's say you're just jumping right into day 3 content or day 4 content, the account, the service account or the service principal that created your resource created the Key Vault. And like I said, Key Vault is super secure. You're not even going to have access to the Key Vault, right? So you can't even import into it. Only the account that created it could. And so if you need to, you might need to give yourself permissions for that. I can't remember if I have permissions. I'm pretty sure I do. Let's go try it because I created the Key Vault. It would have complained by now. Okay, I think we're good. Yeah. So I just created a self-sign certificate and I just imported it into the Key Vault. And I've already created the DNS zone. And so I'll need to grab that DNS zone ID, which is essentially when you go out to the resource, it's going to be the resource ID. And so I have that in my environment variable. Let's just make sure before it's there. Okay. I have the DNS zone ID. Now, here's where you actually enable the feature. And so we're just going to issue another AZ AKS enable add-on command, and we're going to enable the web app routing. And in order for the web app routing to actually work against our DNS zone for us and write the DNS entries for us, we're going to have to pass it the DNS zone ID so that it knows where to go make those updates. And then we'll also have to enable secret rotation so it can actually pull from the Key Vault the TLS certificate. I already did this step. This actually takes a little bit, so we'll just skip over that. And then what we'll do is, well, actually, let me show you this. When you enable that feature, and when you enable, when you're using Kubernetes in general, oh, I don't have access to that. But when you are deploying a Kubernetes cluster on Azure, you may notice that you have this special resource group called MC underscore, whatever your resource group name was. This is where Azure manages resources on your behalf. And you will find things in here like load balancers and stuff like that. You'll also find this web app routing managed identity, right? So it actually deploys, the add-on deploys an additional managed identity for you. And so what we'll need to do is grab that managed identity and actually give it permissions to write DNS zone records. So let's go ahead and do all that. And so this is a little bit of script to actually go pull from that MC resource group, that managed cluster resource group. And then it'll go pull out the managed identity. And oh, I don't have proper permission for that.
I can fix that.
Okay.
We'll get you those rights.
Yeah. All right. So while we're waiting on that, so that managed identity is used for writing DNS zone records, and it also needs to be able to pull out the TLS certificates. Okay. And so we'll just need to set another Key Vault access policy on that particular workload identity, the web app routing managed identity. We'll have to grant that secret permissions to go receive secrets, and then also certificate permissions to just pull the certificates. And,
all right, those are assigned, so you should have rights now.
Okay. So I actually need to log out for that and then log back in.
Sure.
Yeah, I had to do that the last time. So okay. So where was that ginormous command? Here we go. All right. There we go.
There we go.
Yeah.
Much better.
Yeah, much better. So what you'll find now is back over in the DNS zone, under access control, role assignments, you will see that web app routing identity is a DNS zone contributor here, so it can write records. Okay, and we'll do the same for the Key Vault. And so,
welcome, Josh.
Yeah, welcome, Josh. I have the wrong Key Vault name. AKB name equals.
Not to distract you, but what terminal emulator is that, Paul?
This?
Yeah.
It's just iTerm.
Just iTerm?
Yeah. Just iTerm. With oh my ZSH. Okay, so I think this is not found. Oh. Hang on. Easy account set. Multiple accounts. Hang on a second. I have to do this again. Boom. I think I was in my subscription. Yeah. Because I logged out and logged back in, and yeah. All right. All right. There we go. I think. Let's see. Yay. Okay. We're good. We are good. All right. So we have everything in place. We have the add-on enabled. We gave the new managed identity proper permissions to, on our behalf, work against Azure DNS Zone, and then also pull TLS secrets from the Key Vault. So now we need to update these services, because we don't want these services individually to be accessible to the public, we're going to put an ingress in front of it. And so we want to make these internal resources only. And so what I will do is actually run a kubectl patch command. And I'll go ahead and patch these services. So now if I do get service again, and by the way, I'm just using short names for these services. Some of these Kubernetes resources, they have short names. And so you can do K API resources. And you'll see if you're lazy like me and you don't want to type out the whole thing, I use short names all the time where they are applicable. Okay. But yeah, so our application is now hidden away from the public, or actually our services. So if I were to refresh this, I wouldn't be able to access it. But let's go ahead and create the ingress. I'll create the ingress, and here's some things that you need to be aware of when you're creating an ingress. You are getting a open source Nginx ingress controller. However, the ingress class name is going to be different than what's typically used, on the open source thing. You're going to have to make sure that you're using the ingress class name of webapprouting.kubernetes.azure.com. Okay. This enables integration with the Key Vault and the DNS zone. And so when you write your ingress manifest, you're going to have to pass in the special annotation and give it the and you're going to have to give it the TLS certificate ID. And so let me just show this. Echo. Oops. Go. So it's going to be the URI for the certificate. Okay. And then the DNS zone name, I should still have the DNS zone name. Yep. Okay. So let me go ahead and apply this. Right. So ingress is there. Let me see, K get ingress. And just like the service, you'll have to kind of wait for the load balancer to be provisioned, and then you'll see this address field getting populated. Should be there soon. Let's just watch it and wait for that. Okay, let me talk a little bit more about this while we're waiting for the IP to populate. So in our configuration, we have two backends, okay? Let's talk about the web API backend first. So this backend down here, I'm calling it API, and I'm basically saying anything on the path of /API, send it to my API service. Anything that's just requesting /, I want to send that to my web service. And so this way we have one single point of entry for both of those applications, and we're just routing it to different services based on what the request, what the incoming request is. Okay. And now that I have the IP address populated, what I can do is, remember, this is not a real domain name. And so just for testing purposes, we will have to get a second get ing. There we go. That's the command history I was looking for. I'm going to update my host file with this so that it can mimic a DNS lookup from my local machine. So sudo vim. Yeah.
Now, if you actually had access to, or if you're actually managing a domain name that you controlled, then that would just work that way.
Oh yeah, yeah. You'd have to at your domain registrar, you'd have to delegate the name servers over into Azure. Yeah. You'll get.
Yep.
Yeah. There's a bunch of name servers over here that you can actually delegate into, or delegate to, I should say. So let's go ahead and save that. And what's the domain name again? Here we go. So now this won't work. So let me get rid of that. Okay. And this is normal because it's a self-signed. Yeah. It's saying, hey, we don't know where this certificate came from. So there we go. We're all set. The only other thing that I would call out is if you log into the site as admin and you try to go to the admin portal, you may notice that the API for the WebAssembly application is not quite working right. And that's because of the way the configurations are baked into the WebAssembly. And so if you're interested, I'm not going to cover this here, but if you're interested, you can actually update the app settings file. Now that we have a proper domain name, you can actually swap out localhost 5099 with the DNS name, and then rebake your container and patch your deployment, and the back end should be working. So yeah, there we go.
Cool. All right. So now we are on to day 4, and that's back to me. And so Josh, since you joined, just to give you a little heads up in time, if you would like, you wrote day 5's post. Do you want to demo day 5, or do you want one of us to do it?
I don't have anything set up, so if you guys don't mind demoing, I can do the commentary for sure.
Okay.
If that works.
Perfect. Yeah. Yep. That works just fine. All right. So we're back in Visual Studio Code here. And on the wrong page, because that's setting up for me doing the thing with for the next day. I am back. I made sure now I am on the right set of code, or the right branch and set of code and all that kind of fun stuff. All right. So we want to talk about debugging. Day 4 introduces debugging. We also talk about instrumentation. One of the big hurdles that we have when migrating into Kubernetes is, all right, remote debugging is a pain when I'm just talking about web servers, or I'm talking about stuff that's being hosted in like app service or some other type of platform. Kubernetes is this other beast. How do I debug how my app is running in that environment? And we have Bridge to Kubernetes to help us with that. So we're just going to walk through real quick and set up Bridge to Kubernetes, and I'm going to show what that does for us and how we can use that to interactively troubleshoot stuff, live debug, and kind of bring that Kubernetes experience local. So the first step that we have to do is get it configured. And what Bridge to Kubernetes is going to do is it's going to redirect a service of my choice from my cluster to my machine. So we're going to pick the web. And when I run it locally, it runs on port 5001. So I want that one to be redirected. And then Bridge to Kubernetes will wrap one of the existing launch configurations that you have, or you can create your own custom one, or you can just say, no, just start up Bridge, get the port forwarding going, and I'll take care of the rest. Well, I want to launch the web, so that's what we're going to do. The final question that it asks me is, do I want to redirect all requests to my machine, or do I only want requests from a certain subdomain? And that requires header propagation. We're not going to get into that here, but in the article, I've got links to documentation that goes over that whole aspect. And that may require some changes to your application to help pass on host headers. It won't change the behavior of your application, but it just means you've got to do a little bit of extra plumbing. So we're going to do no, which is the default. What that sets up for me is a couple of changes in my .vs Code directory. It sets up a new element in my launch configurations and some new tasks. Those tasks set up some tunneling for us. And then the launch configuration sets up something I can use in my debug pane. So I'm going to go over into debug. Let's stretch this out so you can actually see. So my default one is launch.NET Core Web. I'm going to do launch.NET Core Web with Kubernetes. So that's going to do my bridge to Kubernetes work. We'll fire that up. And we see some stuff scroll past here. It's connecting to Kubernetes. Yep, here we go. I've got a prompt saying that it needs to run a little something. And it's going to run this endpoint manager. And I don't know if you can see right now, but it prompted for elevation because it's got to run elevated because it's got to do some port redirection, mess with your host file, some other stuff. So endpoint manager helps create some of this port forwarding experience. And then it goes right into building my app. And StreamYard liking me there for a moment, but now it's coming back.
Must be all the networking
right.
changes it's
So-
making.
Yeah. Yeah. That could very well be right there. So we're getting to the point. Our app is getting built. And
this
it created
this
local
extension-
endpoints on my machine for all of the services in the cluster. Yeah, it's an extension for VS Code or for full Visual Studio. So you can get this
okay.
experience in multiple places.
Right on.
Yep. So there. Now, this is all scrolling past really quick, and there's some important output from the Bridge to Kubernetes extension. So if I go to the output pane and select Bridge to Kubernetes, this will tell me where these services are hosted and available. So at my local machine, I can go and let's grab this guy here. There's a period in there, so there we go. Well, now let's try that. Or is it just one HTTP? Did I grab the right URL or the right IP address here? Oh, yeah, it's just pausing because it's hitting my breakpoint.
It worked.
my breakpoint. Yeah, I forgot to unset my breakpoint. So it's not gonna render the page yet because it's waiting. Because I wanted to show you that when we hit our breakpoint, one of the things that's really cool about this experience is it uses the existing Kubernetes config and gives it to your application. So when I would run this thing locally, I would normally get the database connection string of using local DB because I'm not pointing it to a different SQL server. If we look at what it looks like to run in development, like there's no configuration for database, right? So you get this default experience. Well, if we use our debug console and now I got to remember how to get my configuration here, but we set a breakpoint. Where's my breakpoint now?
Program.
Dependencies. Here we go. So there's this configuration get connection string. We can grab that little snippet of code and drop it in here and see what we get back. I get back server equals DB. That's the name of the database service. Right. And I get my password SA. I get that some complicated thing from our key vault.
Yeah.
Right. So it's pulling back information from my live runtime environment. So that lets me debug in a much more and explore kind of in a much more in a much more similar environment to where this thing's actually running. Now, the pod is running on a Linux machine and it's in a Linux container. I'm on Windows and I can still actively get in, debug, and see this experience. I can connect into the other services because I've got, right, I could connect a database explorer up to the database at the target endpoint. I could query the API. Bridge to Kubernetes brings that whole experience local for me.
Mm-hmm.
I think it's a tremendously valuable tool.
Yeah.
When you're getting out and running stuff in Kubernetes and you want to see how it plays with everything else that's in that environment.
Yeah.
All right. So there's a lot more discussion then in that article about like instrumentation strategies and things that you want to look for and considerations as you move into a broader microservices environment. We don't have to rehash that all here. So let's jump over then after, now that this is cleaning all up, and get into our last post, which starts introducing some of our secure supply chain concepts. That sound fair? All right. Have you guys played with Bridge to Kubernetes before?
No, that was pretty incredible. I'd not, because debugging for me was like, okay, what pod do I get into, and like really messy debugging experience.
And I just remember like years ago when I used to do .NET development and host it on an IIS server, trying to remote debug an application over there was just painful because you have to also upload all of your debug symbols and things like that. And in this case, I think you mentioned to it on an internal call before, like the debugging comes to you. You don't have to go out to it anymore, so yeah.
Yep. Yeah, we don't have to, we spin up a build. We're running it locally. We could try different things, and it gets even more powerful if we can set up that header propagation and set up a custom domain so that any traffic that's not going to our specific subdomain just goes the regular flow. We're not interrupting anything else on that cluster, but we can redirect a certain amount of traffic, or just our debug, just our individual traffic to the detoured behaviors, and get to kind of see live what that would look like, and how it's running with the runtime environment from that sees from Kubernetes, getting its secrets, getting its config maps, and then there's other capabilities in Bridge to like shim in some of the other features or experiences so that you can control what that all looks like. But we need to talk about some key signing stuff or image signing stuff. So Josh, do you want to just kind of introduce the topic a little bit, and then we'll start going through some of
Absolutely
going through the demos?
Yeah, so the general idea of the post is to introduce and add container image signing using a CNCF project called Notary. So you'll be using the notation CLI to sign the images that are in ACR and all the setup that is required for that. So creating a cert and pushing that up to Key Vault, and then using that with notation to set up and then sign or container images that are stored in Azure Container Registry. And then from there, you can use the post ends where you sign the images, and then you can use those images to prevent unauthorized images from running on your cluster.
And I'll put you on the spot again here.
Sure.
And I think you did a blog post on Dev2 about a whole end-to-end sample where you spin that all up with, I think, was it Terraform or?
Deploying it with Terraform. So setting up the whole cluster with Terraform, and then it also deploys the signing and all that good stuff for the environment, and then preventing unsigned clusters from being deployed with Ratify.
All right. So if you send me the URL to that blog post, I'll throw it up in a banner here too as we're going. If folks are interested and want to see that whole sample. So let's set a couple of variables. And I did just do a quick query to make sure I've got notation available. There are builds for all different platforms. Then we've got a little bit of a key definition here. are keep a policy to guide Key Vault in creating the certificate that we want.
And it's important to put the digital signing there and to restrict the EKUs, because notation actually will reject certificates that don't have those constraints. So if you have a certificate that can do many different things, it won't let you use it. You actually have to use a specified digital signing certificate.
That's good. I bumped into that some when I was when I looked at like some of the Windows logo validation and getting software approved for that, and there were some constraints on how you could sign, or the signing capabilities of the certificates that you were using for that as well. All right, so now we're going to create a certificate. Key Vault is going to generate the certificate for us based on the policy that we're giving it. All right, so expecting a property name. Let's wrap that in. It does not like that. Okay, let's this is different. And let's just pass in a variable and see if that likes it better.
Here string, isn't that what that's called?
Yep.
Still don't like it.
Failed to parse string as JSON. Expecting property name to be enclosed in double quotes. Is there a property name that's not properly quoted? Or is my string was policy, right? Anything
you could throw. Oh, go ahead.
I think this is throwing me off. There's double CN. Let's see if that works any better. Yeah, nope, that did not like it.
What if you output the JSON and just copy and paste it into a new file and see if it throws any errors?
Sure.
That's my trick, my hack, whenever I've got a weird JSON error.
And we'll make sure that this is looks good.
Mm-hmm.
Yep. So let's try. This is a here string without with single quotes. Failed to parse. May have been parsed by the shell. PowerShell uses additional quoting rules. Yeah.
Is it because you're running it from? I maybe just put it in a file and pull it in that way.
Well, that's what I tried at first.
Oh, okay.
Do you want me to try to upload it for you?
I'm gonna try one more thing, and then if you want to get set to try that.
Okay.
Let's try. I'm gonna just grab that whole thing, and then I'm gonna try my little tell PowerShell to stop doing stuff trick.
Oh yeah, that's right.
I think we need what's around that, correct? Yeah. What if you can upload that would be good, because this is not planned so nice.
Yeah. What's the key name that you're using?
So I'm using. Well, here I'll just copy that over to you and in private chat.
Mm-hmm.
Do you have WSL, Stephen?
No, I got rid of that because I was trying to troubleshoot some networking errors. And so I got rid of all the virtualization. But yeah, otherwise. So this is the post that we were referring to. If you want to do notary with and do the validation with Ratify. But yeah, PowerShell and PowerShell and string parsing, and for things that are more that are expecting more of a bashy behavior.
Yeah. Okay, so I set the key name to be notary signing key, and it's
okay, notary signing key, got it.
Yeah. Camel case. So notary, lowercase n to start off. There we go. Yep. Okay. It looks like it went through. Yep.
All right. So now we're going to create a token to access our our container registry, because notation needs a password. It can't. It won't inherit your Docker login.
That would be nice, though. But I'm going to write that as a future request.
Registry. Oh. Now we'll try it. If you put your variables in the right place. Okay, it doesn't like token name, so we'll fix that. Cool. That's what I get for having to translate all the samples from Bash into PowerShell for my local machine.
Should have done that. That's my bad.
No worries. So we got the token. Mm-hmm. We'll get our key ID. We'll see if Paul and I tag teaming this communicated effectively. All right. It looks like we did. Let's make sure. Key ID. Yep, I got a key ID.
Nice.
So now I'm going to add the notation plugin. So this is something both Paul and I bumped into that's a little different than the documentation that would for the example that Josh did, because we all did these demos on different platforms. So Josh worked in Codespaces, which is Linux. Mm-hmm. Paul was working on a Mac, and I was working on Windows. Mm-hmm. And where you put the plugin changes based on your platform. So on Windows, you put it in app data. On the Mac, there's a libraries libraries application support. Mm-hmm. And on Linux, it goes into a .config folder in your user profile.
It's funny that you mentioned that, because I just today saw their new issue from yesterday's community meeting was to add plugin import support for the command line, so it takes care of moving that.
Yes. So if we do AZ plugin notation plugin ls, it will show I found the right location to stuff the thing. So we added our key ID, or did I? Let me see here. Nothing yet. So we'll add our key. Now we have a signing key. And now I need to know what my tag is, because my GitHub Action, my image, I'm going to, excuse me, I sneezed. I didn't know what to do first. Try to hit mute or return. Didn't have much time there. So we're going to get the latest image. The image tag. The image tag will be the same for both the web and the API, because they both use the same GitHub SHA.
Authentication required.
It shouldn't require anything new, because it's my subscription, but let's see if this makes it. Okay. So what show tags not want to play nice? All right, well, we'll just go look. I'm not going to worry about it too much, because I do control.
Just grabbing the tag.
Yeah, I do control the ACR. And repositories, web, tags. Here's my tag. I have had the worst copy paste experience. For some reason, Control C is not playing nice with me.
Funny you mentioned that, because that's what was happening to me yesterday. My Bluetooth on my keyboard was like really, it was just acting weird.
All right, so now we just use notation sign. Oh, I did not change my line continuations. Because consistency. Did I miss a command, Josh?
It looks like Windows is different, where it wants you to set the default. So you just add the key name. So I think there's a key switch, a key parameter for that. Notation sign -- key. And then you can give the key name.
See that helpful little ad
Copilot?
there? Yeah, it's Copilot.
Nice.
Trying to be helpful. I don't want to save. I'm so used to edit, save, edit, save.
That's strange.
Head.
It looks like it's missing the first part of the registry. Is your registry?
Yeah.
That looks right.
Maybe let's wrap that in quotes, make sure it all gets evaluated.
Looks.
Okay.
There we go.
There we go. That works better.
Yes. Hey.
It works.
All right. Good deal. So we now have those things signed. And that takes us to the end of this week's Cloud Native New Year. So next week we have a variety of posts about all different aspects of the cloud native ecosystem. We talk about serverless containers. We'll talk about some tooling to help you bootstrap your taking your app, containerizing it, getting it out in Kubernetes. It can generate all the stuff that we've been working on all last week, some of the stuff we did this week. We can bootstrap a whole lot of that for you with a tool called Draft. And we'll get some information on Windows containers. And that's I think those are the main ones. Oh, and of course, our teammate George will be in next week, telling us all about a bunch of different AKS extensions that can help bring in additional capability into your Kubernetes clusters. So, Josh, Paul, thank you guys for being here and helping me go through all of this stuff and fumble around and make it all happen. And a special thank you to Michael for joining us as well. If you don't know Michael, feel free to find him out on Twitter. He's the NJ DevOps guy. And make sure you check him out. He tweeted about this event, and give him some feedback, what you thought. And maybe we'll do this again.
Yeah.
All right.
I hope so. It's been fun.
Yeah. We'll have to figure out opening graphics and all that kind of fun stuff too.
Make it more professional.
Yeah.
I got to get some LED lights,
Yeah, we can't just YOLO it the whole time, but hey, it's all good. So thank you all for joining us, for watching through, and we'll go check out Cloud Native New Year over at AKAMS. Actually, I could just give you a banner, CNNY, and check out all the posts over there. Like I said, we'll be finishing up next week, but there's also a Cloud Skills Challenge. There's a recorded webinar. There's a recorded Asks the Experts that we did yesterday. So there's a bunch of other content there. And with that, I think we'll wrap it up and call it a day.
Awesome. Thanks, everybody.
See you next time.
Next time.